Okay, this is part 6. It's about factorizing polynomials. Now, just to review your factor theorem, we could say that if P A equals 0, then x minus A is a factor of Px. So that's your factor theorem from the last section. Now we'll use the factor theorem to find one factor, and then we'll do division to find the other factors. So basically what I want to do is, if I had an example like x squared plus 5x plus 6, I want to find both factors that would be equal to that quadratic. So when I say I'm going to factorize this polynomial, I want to find both factors. Okay, so what we're going to do is find one factor first. So let's look at our example. We've got a polynomial x cubed minus 5x squared minus 2x plus 24. And we're going to find one factor first using the factor theorem. And this is a monic polynomial. Monic means that your leading coefficient is 1. We'll guess the factors, provided they exist, using the constant term of the polynomial. In this question, the constant of the polynomial is 24. That's this number here. Okay, so the first thing we do is write out the factors of this last term, 24. So we've got 1 times 24, minus 1 times minus 24, 2 times 12, minus 2 times minus 12, and so on. And we end up with these numbers here. Okay, we only need to find one factor. So we'll just choose one to start. So, and check with the smallest numbers first. So the smallest number here is 1 and minus 1. So if I put 1 into my polynomial, I'll get 18. Okay, now because this is not 0, x minus 1 is not a factor of the polynomial. And then I'll try minus 2 as another number, for example. When I put minus 2 in, I'll get 0. Okay, which is good. This is what I need. That means that x plus 2 is a factor because the remainder is 0. So what I'll do, I'll divide my x plus 2 into the polynomial, which was x cubed minus 5x squared minus 2x plus 24. So we have one factor, x plus 2. This came from the factor theorem. So I could write that again. P minus 2 equals 0. The remainder is 0. Therefore, x plus 2 is a factor. So we get our factor first. This is by guessing. Okay, we need to guess the factor. And then once we have our factor, we divide it to find the other factor. So I'll put x squared times x cubed, x squared times 2, 2x squared, and then we subtract. Minus 5 minus 2, minus 7x squared. Bring down to minus 2 like before. Minus 7x squared, this must be minus 7x times x, minus 7x squared, minus 7x times 2, minus 14x. Then we subtract that. Minus 2 plus 14 is going to give us 12x. Bring down to 24. So this number must be 12 then. So 12 times x, 12x, 12 times 2, 24. And when we subtract, we get 0. That 0 is this 0 here. So we know we've done it correctly. If you don't get 0 here, you'll need to check your calculation, or you need to check back that your factor is correct or not. You should get 0 here though. That means your polynomial could be written as x plus 2 times the quadratic x squared minus 7x plus 12. But you see, we're not actually finished yet, are we? We can still factorize this quadratic here. So we've got x plus 2 as the linear factor. This is your quadratic factor, so how do we factorize that? So that's going to be x minus, what is it, x, let's put them out first. So minus 3 minus 4, just looking, check that. So minus 3 times minus 4 is 12, good. And when you add these two numbers, you should get the middle number here, minus 7. So this is correct then. So we have 3 linear factors. These are called linear factors. So we've got x plus 2, x minus 3, and x minus 4. If you want to check these factors are correct, you need to expand again and check you get your original polynomial. Now, the rational root theorem, you may not need to use this. It just depends on the question. Okay, when the polynomial is not monic, so for example, in this case here, we have a 2. So this is not a monic polynomial. The leading coefficient is not 1. Then we can use the rational root theorem to find rational roots. Note that the method in the previous section can still work. However, this method can help you find rational roots that are fractions. Okay, some rational roots will be fractions, and you can't easily guess those. So how does this theorem work? What we do, look at your last number, your constant number, which is minus 12. The first thing you do is write out the factors of minus 12. So 1, 2, 3, 4, 6, 12, and plus or negative. Okay, because remember, minus 1 times minus 12 and 1 times 12 both give you 12, for example. Actually, we want to make negative, right? So plus 1 or negative 12. Okay, because the last term is negative 12. So we write them all out, including plus or minus for each factor. Now we look at the leading coefficient, which is 2, and we do the same. So 1 times 2 is 2, and also minus 1 times minus 2 is 2 as well. So these are the factors of 2. So the possible rational roots, we need to check this. So put the factors of minus 12 on the top and put the factors of 2 on the bottom. And you write out every possible combination. Seems like a lot of work, doesn't it? So we've got the first one, plus or minus 1 on plus or minus 1 is here. That's one combination. So from that, you can see you got 1 on 1. You could have minus 1 on 1, or 1 on minus 1, or minus 1 on minus 1. So from that, you'll get 1. This is minus 1. These two are the same. This is 1 and this is minus 1. So we don't actually need those two. So here are two numbers that we can try. Then you can keep going. You've got 1 on 2, 1 on minus 2, minus 1 on 2, minus 1 on minus 2, and so on. So I'm not going to write them all down, but you get the idea. Now, what I'm going to do, I'm going to check this first one, 1 on 1. That's what I'm going to do here. Okay, so because 1 on 1 is 1, I'll try 1. So let's put 1 into your polynomial. So you got 2 times 1 cubed minus 12 times 1 squared plus 22 times 1 minus 12. And we want to see if we get 0 or not. So you're going to get 2 minus 12 plus 22 minus 12. 2 minus 12 minus 10 plus 22 minus 12. And that's going to equal 0. Okay, so P1 equals 0, which means that x minus 1 will be your factor. And that's your factor we'll use. Okay. Actually, this method here is probably not going to be needed to be done. You can use the previous method where we just write out the factors of 12. Okay. So I think in your question, you can just look at these ones. We don't need to do this method here. It may not help you find other factors easily. And if you only get 1, that's all you need anyway. So let's divide the x minus 1 in. And then we divide it into our polynomial, which was what we get from here. So 2x cubed minus 12 times x squared plus 22x minus 12. Let's see how it goes. So as before, this will be 2x squared times x, 2x cubed. 2x squared times minus 1 minus 2x squared. Then subtract. Minus 12 minus 2, that's minus 10x squared. Bring down to 22x. And then it looks like minus 10, right? Minus 10x. Minus 10x times x, minus 10x squared. Minus 10x times 1, 10x. And we subtract again. 22 minus 10 will be 12x. Bring down to minus 12 here. So we'll have 12. 12 times x, 12x. 12 times minus 1, minus 12. And subtract, we'll get 0. So that confirms that x minus 1 is a factor, this number here. So we could write that out as x minus 1 times our quotient, which is 2x squared minus 10x plus 12. And when I look at this, I see 2 is a common factor, isn't it? So how about you take out 2? Take 2 as a common factor out from this quadratic. So we'll have x squared minus 5x plus 6. And we can factorize that quadratic. So let me put the 2 in the front here now. 2x minus 1 times x squared minus 5x plus 6. Now we can factorize this. X minus 1. So that would be x minus 6, x plus 1, right? Minus 6 times 1, minus 6. Minus 6 plus 1, minus 5. Okay, so these are your 3 linear factors here. This is your factorized polynomial here. That would be your answer for that one. Now, some questions you may recall from grade 9, we did polynomials and we did sum and difference of cubes. So for these ones, we don't really need to do the polynomial division. We can factorize them quite easily. So x cubed minus 27, you remember this would be the difference of cubes. We can write it out in this form here. So this would be same sign. Then we change the sign to opposite. And then the last sign are always positive. So if you remember SOAP, you'll remember what the signs are. Same, opposite, all positive. Okay? Same as this one, opposite sign, then all positive here. So x cubed minus 3 cubed. So change your number to a cube. 27 is 3 cubed. So using the difference of cubes here, we would have x minus 3 as the first factor. And then we would have x squared. Then we change it to positive. And the rule is AB, so 3 times x, the number first, plus the last number squared here. So that would be 3 squared. And that's x minus 3, x squared plus 3x plus 9. Now this last term generally can't be factorized, so you leave it like this. So don't try to factorize that. You can use your quadratic formula to try and solve an equation, use with equals 0. You can't do it. Okay, so just leave that as quadratic. In this question, we've got 64x cubed plus 27. So let's change your 64 to 4x all cubed. Remember that? 4 cubed is 64, x cubed is x cubed, and 27 is 3 cubed. Then we do the same. So our first factor would be 4x plus 3, same sign. Then we change the sign, but the first term is squared. So 4x squared plus minus, same, opposite. Change the sign. So we got the same sign, then we change to the opposite sign, negative. And that would be 4x times 3. And then we go back to positive. And that would be 3 squared. So we'll have 4x plus 3. And this would be 16x squared minus 3/4 of 12x plus 9. Again, don't bother to factorize this. So if you see any question that is like you saw last year, difference or sum of cube, just use this method. Don't bother to try and divide it. Not necessary. We can use these two rules here. Okay, here's some questions for you to do. Just refer back to the examples I've just gone through. Okay, so when you're guessing a factor, let's start you off. Look at your last term, minus 1. So what are the factors of minus 1? Just minus 1 and 1, aren't there? So you need to try P1. What do you get? Do you get 0 or not? And then also try P minus 1. This will give you the first factor. So I want to know which one equals 1. And then use that as your factor that you divide into your polynomial. The same here, we've got 5. So what are the factors of 5? So you've got plus or minus 1, plus or minus 5. Always start with the small numbers first. So you try P1. What do you get? Try P minus 1. If these don't work, then you need to try P5 and P minus 5. Okay? And then divide that polynomial and find the other factors. Okay, this one is 6. So you must be trying plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And same for this one here. The sign doesn't make any difference. Now in this question, notice that you've got a common factor already, which is actually 2x. So to save you some time, factorize out the 2x first. Then what is left in here? You may find you don't need to do any division with this question, okay? For this question, you've got a minus 6 here. You could use your rational root theorem, but how about firstly, just try, keep it simple. Just try plus or minus 1, plus or minus 2, plus or minus 4 first. Okay, don't worry about the minus 6. I think you will get a factor from these ones here. So try 1 first, then you try -1, then you try 2, etc. Okay, you only need one that works, and when you find that one, you divide it into your polynomial. Okay, so have a go at those, and I look forward to seeing your working. Okay, see you next time.